Hello everyone, welcome to this video series on examples on calculating time complexity of a given code snippet. So today we are here with another simple example to find how do we calculate the time complexity. So here is a for loop given for x equal to 1, x less than or equal to n, x into equal to 2. So here the for loop will start with 1, will execute as long as x is less than or equal to n, whereas the value of x is getting multiplied by 2 every iteration. So here you can see, if you look into the for loop, we can see that the for loop terminates when the value of x is greater than n. So let us see what is the value of x. First time the x is nothing but 1. X is 1 here. So next iteration, the value of x is 1 into 2, which can be represented as 2 to the power 1. Second time it is 2 into 2, that is 2 to the power 1 into 2, which is equal to 2 to the power 2. Third time it is 2 to the power 2 into 2, which is equal to 2 to the power 3. And we can generalize it by saying that 2 to the power of k. So the value of x, when it becomes greater than n, the loop terminates. That is, when this 2 to the power of k is greater than n, the loop terminates. So this can be written as, if it is 2 to the power of k is greater than n, k can be written as log n. So hence the time complexity of this small code snippet where x is getting multiplied by 2 each time is nothing but log n to the base 2. Now if it was getting multiplied by 3, every time x is getting multiplied by 3, the time complexity will be order of log n to the base 3. Hope you understood this. Now int second example is int a equal to 0, I equal to n. Again, this statement alone will take constant time because it is getting executed only once. And we have a while statement here. While I is greater than 0, a plus equal to I and I is equal to I by 2. So the condition is based on I and the value of I is getting divided by 2. So let us say n equal to 16 given here. First time the value of I is 16. Next time it get divided by 2, it becomes half of it, that is 8. Again next iteration 8 by 2 which is equal to 4. Again 4 by 2 which is equal to 2. 2 by 2 equal to 1. So when does the while loop terminates? It continues as long as I is greater than 0. It terminates where the value of I becomes less than 0. So we can generalize it by saying it is nothing but 2 to the power of k, 2 to the power of 1, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16. So it can be generalized as 2 to the power of k. When it is it becomes less than n, the value of n, the while loop terminates. So k can be represented as log n, hence the time complexity is nothing but order of log n. Here is a code example given. There's a function called prime which take one argument n, that is the number of input. We have a for loop here for I is ranging from 2. Look into that. As long as we were seeing I starts from 0 or I from 1, here I is from 2. I is less than n plus plus I. And if n mod I is equal to 0, return false, otherwise return to true. So this statement will get executed n minus 1 time because I is starting from 2 and it continues until I is less than n. The statements within the for loop, since the for loop is getting executed n minus 1 times including the final conditional check, the statement inside the for loop will get executed n minus 2 times. So the time complexity of this particular function, that is f of n equal to n minus 1 plus n minus 2 plus here there is a return true statement which is getting executed one time, is that highest degree of highest polynomial is n, hence the time complexity is order of n. Yeah, that's all for this session. We'll come up with a new session on a few more examples on calculating time complexity.